All right, and I think we're live. Hey, everyone. Good morning, good afternoon, good evening, wherever you're at today, joining us here on our December 2023 LimaCharlie LC webinar. Excited to have everyone here. This is the December edition of Loud and Clear. Just a quick note for those of you who may be joining us here for the first time. Loud and Clear is our LimaCharlie webinar series where we use this time and take an opportunity to talk about either a feature of the LimaCharlie platform, an approach towards detection and response, something that you might want to look for in telemetry, crafting detection and response rules, really like kind of a grab bag or a mixed bag of topics, but nothing set in stone. The nice thing about it is it gives us a chance to talk about a certain thing for a period of time and then find ways to go and explore those different topics and dig into them further if we need to as well. Great to have everyone here with me today. I'm excited, looking forward to this topic. This one is LOL bins, or I'm going to read through the abstract here really quick. LOL bins, or living off the land, is a technique that adversaries have taken advantage of for quite a while now, and is something that is worth every detector and responder out there to be aware of. So if you're in the detection engineering space, if you're in a SOC analyst role, SOC management role, even if you're upwards in that management level to executive level, it's helpful to know and understand how adversaries can do what they do inside of an environment. And it may sound a little weird because I know for some of you, especially those of you that have done incident response for many years, or maybe even gotten into malware analysis, you might be thinking, well, Matt, this is an old technique, right? Adversaries have been doing this for a very long time. And I agree with you, but I'd also contend and say that adversaries are going to continue doing what they're doing as long as it's successful for them to do it. So they're still finding success. So we want to continue to find ways to be a little bit more successful in detecting and seeing what's happening and what's going on. So for that reason, I brought together this episode for this particular month. This is also our final closeout episode of 2023. Hopefully everyone's noticing it's December 2023. I think I've done at least one webinar a month this year from the Loud and Clear series. You might have all caught some of the LC 101s a little bit earlier on this year where we had more kind of introductory things. But we've had a lot of great content this year, and I'm excited to say that Loud and Clear will definitely be back in 2024. This series is not going away at all. We're going to continue to pull and pry on little topics here and there throughout, obviously, the foreseeable future. That note, I do have a request for the audience here, which is, those of you who have kind of either walked with me through these journeys or have been on these Loud and Clear series or understand what it is we're looking for here, I would highly recommend, if you're in our Slack channel, if you've got a way to get a hold of me, be it Slack, LinkedIn, Twitter, Mastodon, whatever it might be, feel free to please send me a message, send me a DM, slide in those DMs and say, hey, Matt, here's an idea for a topic or a thing that I'm exploring or a thing that we're seeing. I really like to gear these webinars as much as I can towards things that are being observed in the wild or things that folks are seeing out there. Because it's really easy to say, well, this is a technique that I'm really nervous about, but the way that adversaries are using stuff in the wild might present a different option or a different approach there. So for that reason, highly recommend, folks, let's make 2024 the year of content for whatever it is you'd like to see. And we will look at delivering to the best quality that we can, obviously utilizing the LimaCharlie platform and giving everything we can towards that visibility, those detection and response capabilities, those automated, those integrations, everything we can. We're all here for it. All right. So I've got a few things that I want to cover and talk about today. I don't have a set of slides. Y'all know by now, I don't really speak to slides. I like to walk through examples and see what the data looks like and what the concepts are that we're talking about. I want to start out today by really exploring the idea of living off the land for those of you who may not be too familiar with it, or some of you may not be familiar with just how wide of a scope living off the land actually is. When a lot of folks think of living off the land as a concept, they get the general idea. All right. And let's back up and let's explain that so we can set that foundation for everyone here. Living off the land is an idea that as an adversary, if I get into a network or get into an enterprise or get onto a system, whatever the final destination might be, I don't want to bring in my own custom malware or my own custom tools. Now, I would love to throw the question out to the crowd, but I'm obviously going to ask it and then go through and answer it as well. Why would adversaries not want to do that? Why would we want to prevent bringing our own stuff. Imagine I've got this team of folks behind me who are creating all this awesome malware and doing all of these things. And then I get into a victim environment and I say, you know what? I don't really want to use all that cool stuff that you've built. Feels a little backwards, right? To have all these amazing tools at your hand and then not utilize them. Another way to think about this is sometimes adversaries do bring in tool sets, but those tool sets actually utilize binaries and capabilities that are already built into the operating system. So if I think about one of the one of the, the one that gets beat the most in a lot of these types of sessions is Cobalt Strike. Cobalt Strike is a perfect example of a post exploitation toolkit that utilizes living off the land binaries or utilizes system functionality very, very heavily to achieve what it does. So there's a little bit of a mix up here, not a mix up like a mistake, but more of a mix of use of tools. I am rolling in with custom malware, aka the beacon, the stager, the part of Cobalt Strike that I'm communicating with. But that tool itself is doing what it's doing and remaining stealthy by living off the land. So in some cases, adversaries are living off the land directly with things that they know about how toolkits work or how binaries and software work. In other cases, adversaries are utilizing a toolkit which puts them one step away, but they're still living off the land, maybe sometimes without even knowing it. Now, one of the ways that we as defenders get really good at detecting these types of activity is we get smart about how adversarial tools do what they do, what it means, what it looks like to live off the land, and then to go through and how to detect some of those. Because there is, unfortunately, a very, very big downside to living off the land as well from a detection perspective. And the big downside there is, guess what? If they're living off the land, this is activity that is going to look and appear legitimate. That's one of the issues of living off the land is you're going to be dealing with stuff that looks like it might potentially actually be legitimate, but I'm not entirely too sure. And that's kind of where we get into today's particular session. That's where we get into, well, how do I go through and how do I understand, what it takes, what it looks like to actually live off the land. So we're going to go through a bunch of, different examples here today. And I think it's going to be very beneficial, especially for those of you writing your own detection and response rules. Those of you who might be looking to detect some of the latest and greatest adversary activity. There's a lot of folks here who use LimaCharlie who I know are MDRs, MSSPs. Those of you in enterprise SOCs, it's going to be great for everyone to have this experience and know how to walk through these different types of tools and capabilities. All right, I'm going to bring up I'm going to share a little screen here with us. I've got quite a few things teed up and ready to go, but I wanted to start out first and foremost by and I'm going to try and find the best type of way to present this here. I think that might be it right there. I wanted to bring up a few resources that we're going to use to understand living off the land a little bit better. And I've got a few different things teed up here. We're going to walk through each one with as much detail as we can. I'm going to start with the basics of living off the land, really the genesis of where this idea came from. And let me be clear. When I say idea, I don't mean adversaries using this. I mean us as defenders cataloging and keeping an eye of what's happening here. These tools, these scripts, these libraries, these whatever, we'll talk about those categories in just a minute here, but all of these different things have sometimes been referred to as LOL bins, living off the land binaries, but there's a kind of a compendium here called living off the land binaries, scripts, and libraries, or LOL BAS. This is one of the best resources out there for understanding and getting an introduction into what an LOL bin, an LOL script, or an LOL lib might be. And you're going to get tired of hearing me say the letters LOL. I'm going to do my best to try and minimize what happens there. But, nonetheless, it's an important part of understanding what's happening here. But with that said, so let's take a quick look at kind of what the LOL bin side of things means. Now, we have to insert one umbrella, one caveat, one delineator here. We're going to have LOLs for Windows. We're going to have LOLs for Linux, and we're going to have LOLs for Mac. Primary 3 operating systems, just going to be the way that it is. Now, I wish that there was a consistent naming scheme amongst them. However, unfortunately, it seems like each one has become kind of a little bit of a pet project, but they get the names that they get. There was a very good inside joke just dropped into the chat. Nick, that was a really nice one. I totally understand what you mean there. I like that, but I'm going to keep it LOL, but that was clever, sir. That was clever. All right. But that being said, let's talk about and look through what's going on and what these are. Okay. First off, we're very, very powerful as defenders because we know how these things are used and how they're abused by adversaries, how they're utilized. We're able to categorize and look at them as such. So in this particular site, there's a list, and take a look here. I'm just kind of generally scrolling down to try and identify a bunch of different types of things. We'll pause here at the bottom of binaries. Notice that these are sorted alphabetically. At least we tried to sort them alphabetically as much as they can. While I'm here, by the way, a huge props over to the folks over at the GitHub repository, all 77 or 91 contributors who keep this thing going. Thank you for everything that you do, because you make this project an awesome one to reference. But when I come back here, there's a list of a bunch of different executables listed here inside of Windows. We know we're looking at windows.exe, and luckily, there's a lot of different references just on the main page here, and I can search through these. So there's 198 binaries called out here, things that I can search for if I want to. So if I wanted to search for bitadmin, for example, bitadmin is a Windows binary that I like to pick on a lot, but I'll tell you why. Take a look at all the different functionality that this thing can do. Second column over, there's our functions list. This is where they've identified what the binary is capable of doing. And when you look at this list, I want you to think that is a manner in which the binary could be abused as well. And then we get over far right, we're looking at the attack techniques that are associated with this as well. And I'm a big fan of kind of having these things linked up, because guess what it allows me to do? It allows me to quickly hop over to the MITRE's attack matrix and see how exactly is this thing used? How has it been used in the past, or where has it been seen before? So I get that really good one single link correlation between a tool I'm looking at and then where it's been seen before, threat actors who have been associated with it, how it's being used, so on and so forth. And you can see as I'm scrolling through this list here, right? Ingress tool transfers are a widely used technique by a lot of different groups that are out there. APTs, financially motivated groups, opportunistic ones, all kinds of stuff. But if I start to dig in a little bit further, we'll notice that there's also other attack techniques associated with this. Where the MITRE attack matrix becomes extra useful is I can also just do a quick search for bitadmin to see where has this particular software been identified. How has it been utilized? And you'll notice we've got some of the exact same MITRE techniques here and the different groups that have been associated with this. So without even digging into this tool any further, I'm already able to start to build a little bit of an idea from an intel perspective. Who utilizes this? How have they been utilizing it? What types of things they've been doing, so on and so forth. And it's a very, very useful resource to have kind of upfront without, again, even digging into it. Now, I tend to look at these types of resources, folks, as taxonomies. I like to look at them as libraries, as references. I don't want to think about being MITRE attack compliance. I don't think that's a thing. But what is a thing is for me to be able to get on a webinar or get on an incident response report or a debriefing call and say, the adversary used bitadmin to download their malware, and then they went da-da-da-da-da-da, and for no one in the room to be able to say, wait a second, I've never heard of this bitadmin thing. What is it? Where do I find more information about it? And the answer I have is nothing and nowhere. That's how threat reports used to be back in the day, is we would have to describe a tool that an adversary used, or at least I should say we would list a tool, and then we'd have to define it, and then we'd have to describe it. And the next thing you know, I've spent 3-4 pages of writing on describing what a single tool does. So all of that goes into an appendix. Multiply that by the number of tools that adversaries use, and now I've got an appendix that's longer than the original report just to try and define what adversaries do. Luckily, I've got resources like LOL BAS and MITRE attack that saves me from having to go through that. But let's stick back with our LOL bin. Let's dig a little bit further into what bitadmin is, how it's been used and abused, and kind of where we've gotten these awesome resources from. So again, now let me back up and remind everyone, these are legitimate Windows files. We're looking at Windows right now. We will expand the same concept to Linux and Mac very shortly. I should say Unix-based and Mac. However, these are Windows files right here. So every file that you see listed is default built in mostly to the Windows operating system. I say mostly because there's some files that may be part of an add-on or an additional package or something like that. However, I'm going to say 99% of the time, if not 100% with a lot of confidence, these files are going to be included in a default Windows build. Because they're there by default, my adversary isn't needing to bring anything new to the table. They're not needing to download or create any new malware in order to achieve a functionality. And that's where that living off the land concept comes from. So let's dig a little bit further into Bits Admin, as I mentioned. Bits Admin is a tool that is built, again, into Windows, and it's used to manage something known as the Background Intelligent Transfer Service. Believe it or not, this is something that occurs all the time in the background of your Windows operating system. There's just a strong chance you never know about it. It's a binary that's used by the operating system, but it's not one with a pop-up or any sort of crazy reference. Hey, I'm doing this thing. Did you know about it? It's more like the operating system is breathing. Not that I'm personifying it, but it's just stuff that happens in the background without you as a user even knowing about it. Bits Admin is one of those. But take a look at all the great resources we get in this particular site. I get paths where it should be located. I get resources associated with it. I get acknowledgments. We even get links to detections that have been written for various platforms in here. And then we get, and notice the big headers here, alternate data streams, download, copy, execute. I get examples of what that thing looks like when it runs. What that thing looks like when it runs, I can see what that code looks like. I can see what that particular command line would look like. So if I wanted to say, hey, well, I'm nervous about an adversary using Bits Admin to download a particular file, what would that look like? Well, let me go search through 400 threat intel reports to see if I can find one. Not at all. The LOL Binaries project does a great job of circulating and providing those for us. But I'll tell you all right now, here's one of my favorite parts about this whole thing. They even go further into the privileges that are required, as well as the operating systems that have this included. And take a look at this range, folks. Vista, all the way through current Windows 11, has this particular tool built in. And that's another reason why adversaries love to live off the land, because it opens up their wings to versatility across all the different operating systems. I can fondly remember days where malware didn't run in a particular OS because of some other permissions or some other control or some other thing that had been implemented. Whereas if I'm an adversary and I want to use Bits Admin, I need user privileges as indicated here. And there's a good chance it's on the OS that I've landed on or that I've breached or that I've taken it over. Guess what? That's going to allow for a really easily flexible toolkit. It's going to be something we're going to want to be aware of as we go through and kind of put these together. Now, interestingly enough, I'll make a note and say that the download capability and the alternate data stream capability, according to our project here, according to the LOL Binaries project, has been ported to Windows 11. But take a look. The copy and execute capability has not. The copy and execute capability stopped at Windows 10, again, according to this particular source right here. That's very, very useful because it may also serve as a little bit of a hurdle or a limiter for my adversary as well. And we'll talk in a few minutes about why that's an important consideration about knowing where an adversary can or can't do a particular thing. But that's a good example using Bits Admin. I'm going to leave this one up here because I want to talk about in just a few minutes about some detection opportunities when I'm looking at LOL capabilities. But we need to expand our definition and expand our scope of living off the land a little bit. The next one I'll get into is something called living off the land drivers. Now, we're breaking away from scripts and binaries. We're still inside of the Windows operating system, but this is another project that is associated with gathering living off the land drivers, a list of Windows drivers that adversaries can use to bypass security controls and carry out attacks. So we're seeing another use and functionality here of components of the Windows operating system, not just I don't have to introduce my own malware, not just operating system versatility, but also, oh, wait a second. These files are likely also on an allow list. They're likely allowed to run by antivirus or EDR detection tools. In fact, there's a very good chance that I might be able to run these things without even being noticed because, again, they're allowed, they're part of the operating system. And take a look, everyone. I'm just going to scroll down here. You're obviously not going to memorize or write any of this down, but take a look at all these different drivers that have been associated with the Windows operating system and ways that they can or have seen to be abused. We'll dig into one a little bit further here and notice that not only do we get very, very similar capabilities, but they've also gone through and they've identified areas. Hey, here's where this thing has been seen to have been abused or where it's been part of a particular thing. All right. Now, interestingly enough, in this case right here, C.sys is identified as a vulnerable driver. This one does not have as much information as I would like it to see, but I do like seeing the fact that I do get a SHA-256 hash. And then if we dig a little bit deeper, and maybe we'll go try and find a more verbose source in this case. Let's try and find one that hopefully might have a little bit more information about it, I hope. Let's see. There we go. This one looks a little bit better. So here's an example of ncm.sys as a vulnerable driver. Admittedly, it's got an older CVE associated with it, but it is there. You're able to grab a copy of that file if you'd like. I love this feature set. I love this capability because if I've got a reverse engineering team or I want to dig into these files a little bit further, this is going to be very useful to have. Some commands we could use to potentially run this thing. There's some detections built in that I could look at from a Yara perspective, from a Sigma perspective, from a Sysmon perspective. I can see where this thing is able to run, the privileges that are associated with it, and what an adversary might use it for. We get into the CVE details, some blog posts about how it may be used, and then we get into different PE information, certificate, import details, export details. I'm just scrolling quickly. I don't want you to memorize all of this, but I want to go through and show you just how much detail gets pulled out of that tiny little nscm.sys file. Again, every little metadata point that gets pulled out is an opportunity to create a detection. Now that's Windows. I have not covered the entire scope of Windows. We didn't talk about scripts, of which are located at the bottom of our LOL BAS project. And there's a few other ones we didn't get into either. But again, the general concept of things built into the OS that I could take advantage of is what I want you to look at right here, right now. That's Windows. Bucket number one. Bucket number two, let's take a look at Linux or Nix-based systems. Now, as I mentioned, unfortunately, these are not consistently named projects. They are almost pet projects in some case. And someone in this case decided to call the Nix-based resource GTFO bins. I'll let you read through the description as to why this is the way it is. But long story short, the goal was mostly privilege escalation. Get me out of this restricted shell, or get the F out of this restricted shell, hence the name. I'm reading, I'm not quoting. That being said, another very, very useful list in being able to understand how, as an adversary, could I potentially abuse things that are built into the Linux operating system and escape out of a shell or set up a reverse commit shell or some sort of other capability here. So very similar format. In fact, this is the one that's probably the closest to LOL BAS. I get a list of binaries. Some of them are, again, going to be included in the operating system by default, such as, for example, let's see, like but that may depend on the age of the operating system. Base 64 is another one, but let me see. I think there's one on here. I'm pretty sure Vim is in here. Yeah, rvim, Vim. So Vim, for example, is one that has a lot of different capabilities associated with it, a lot of like things that adversaries might want to do and might want to use it for. And it is definitely likely built into every operating system that's out there. Whereas binaries like Ansible Playbook or Ansible Test are likely going to be installed as a result of the Ansible toolkit or the Ansible platform if you're using that. But regardless, point still remains the same. An adversary walks into an environment or, walks into an environment and ends up with a bunch of different tools that they can use and abuse if they want to. I'm going to pick one at random. Let's go back to Vim just because it was there and I really just want to kind of pick on Vim for a minute here. Look at all the different capabilities that you get with Vim. I can do things like setting up a reverse shell, file read, file write, escalating to sudo capabilities, file download, so on and so forth. A lot of unique things can be done here. And just very similar to what we saw in LOL BAS, GTFO bins, it goes down a step further and breaks down how to utilize each one of these commands. Now, if you've a Linux operating system user, you've done some work in Linux before, or I should say Nix-based systems, and you've never really kind of dug through this site to see ways that these things can be abused, you're in for quite the read, because there are lots of ways that you can go through and actually utilize these files. A lot of cases, escaping privileges or bumping up to things like sudo and whatnot. Again, it really comes down to what's available in the operating system, but there's a lot of interesting capabilities that can be used here. Again, I'm going to repeat this again when we get to Apple. Every single time someone shows me a way that a particular tool can be abused, I see a detection opportunity. I see a way to say, oh, wait a second. If that thing is bad, I can go and look for it inside of an environment, especially because it's likely going to stick out as something that I'm not going to see someone do normally. We'll talk about that one in just a moment. There's our Nix-based systems. Third and final category is going to be Apple. This is one of the most clever compendiums here, primarily because it is not GTFO, it is not LOL, it is Lubins. And before any of those of you with a British sense of humor or a background in the UK make any jokes, Lu stands for living off the orchard. And I just happen to love, living off the orchard. And I just happen to love when folks do a little tongue-in-cheek play on word things like that. The apple living off the land is living off the orchard, and I love it. But nonetheless, same exact approach. This is a list of binaries, tools. You can notice all the way over, we see the different tactics lined up here. This one's very cleanly organized. It looks like an Apple app, but this one is sorted into what types of tools can be used for things like discovery, defense evasion, lateral movement, persistence, so on and so forth. And again, you might not be familiar with the tool called Ditto, for example, right? But it is a command line utility that's being used inside of Apple systems. And if I just take a really quick look here, and this is not going to be on screen, but I'll tell you right now, just digging into a remote Apple terminal, the Ditto is an application that's there. It's available. It just runs. So, the point being, this is something that a lot of folks might not be aware of, but adversaries do know and likely utilize this in some of their attacks or some of their approaches. And just like everything else, I won't go through this too much, but just like everything else, we go through and we see just how these different types of tools can be abused, what those commands look like, what types of tools or what types of parameters are needed, so on and so forth. Interestingly enough, I wanted to point this out just because some of you may be looking at this like, wait a second, that doesn't make any sense. We're looking at a Mac system. Why am I looking at a DLL hijacking? Well, folks, this is another opportunity. Just because DLLs are commonly associated with Windows systems, there actually, of course, are dynamic libraries associated with Apple systems and Linux as well. So the idea of replacing a legitimate library with a malicious one, or DLL hijacking, or DLL search order, or some of the other DLL-based vulnerabilities, they're sometimes not operating system limited. Quick little pro tip, something important to know there. All right, but nonetheless, let me just kind of go through and review really quickly some of the things here before we get into like looking at this from a LimaCharlie perspective. Living off the land is a concept, again, of I want to utilize binaries, scripts, drivers, whatever it might be that's already on the system so I can fly under the radar and not get too much, not provide too much content in getting detected there. We've got some great resources to go and understand how I would go through and detect that and what that might look like. Let's talk about how we now identify what we would be looking for. I don't want to open up LimaCharlie just yet and start writing a detection and response rule, primarily because it's really going to come down to, well, Matt, what is it that we're looking for? So here we go, right here. Here's an example. I've got a detection and response rule written that looks for the evidence of bits admin running inside of an environment. And if I go and I replay this rule against my data set here, now we quickly jumped into LimaCharlie. So let me explain what's going on here while that replay rule runs. I've written a rule that looks for new process events and looks for instances where the command line contains the word bitadmin. Here's what I did. I went over to that LOL BAS site right over here, and I saw that bitadmin is a tool that can be used maliciously by the operating system. So I came right back here and I said, show me every time bitadmin has run. And I'm going to have to expand my search a little bit here, which is totally okay. But luckily, this is a pretty wide casting net, meaning I'm going to get every instance, every time bits admin has run inside of this particular environment, because I'm going to scroll back across all that telemetry there. But here's where it's interesting, folks. Remember, these are legitimate binaries, legitimate tools in an operating system. This is not something that's inherently malicious. So I'll let you figure this part out for yourself. If I write a tool that just looks for evidence of bitsadmin.exe executing, I'm not really observing malicious activity. I'm looking at the execution of a legitimate binary. So I want to go a step further and say, all right, well, if this thing is normal and it's blended in, what do I know, or what can I find out about the way that this thing will be abused in order to have a better understanding or a better definition of how to find it? So let's go back to our resource. There's a lot of things in here we want to pick on to look for where this particular event might have tripped. Now, I'm going to hop back here because I know we have some hits. I intentionally ran some bits admin stuff in the past. We do have an event here for bits admin being run. We've actually got, if I'm not mistaken, 3 events of bits admin being run. Let's take a look at kind of what these events look like from a LimaCharlie perspective. First off, there's our command line, just straight up bitsadmin.exe being run. No parameters, nothing provided after it whatsoever. We get our executable, the full path. We get our hash information about that thing. And then I get some different metadata and routing details. But what I really care about from a process perspective is all going to be in this little block. And I'm going to try and zoom in on just this little block right here. Bits admin being executed. The parent of bits admin in this case was cmd.exe. There's a bunch of hashes and identifying information, but that's kind of the core of this event that I'm looking at. Let me go back to my resource. Is there anything in here that can tell me a little bit more about how or where bits admin might be abused? Well, here's the first one. The first one's going to be the path where it should be. Now, my colleague Eric Capuano called this out on Defender Fridays a couple weeks ago, but there's actually 2 locations in most Windows operating systems where a particular binary can be located. And guess what this is for? And hopefully some of you have looked at those paths long enough now to know this is the difference between 32-bit and 64-bit. But the easiest thing to remember about Windows is, guess what? They're actually reversed. The 64-bit binary is in System32. The 32-bit binary is in syswile64. There's a long explanation, but long story short, WoW is Windows on Windows. So this is actually the 32-bit emulator, for lack of a better term. But what you're looking at here is 2 versions, bitness being different, of the exact same executable, exact same functionality, exact same capabilities. This is an important distinction for us from a detection perspective for a few reasons. Number one, I obviously want to look for any instances of bits admin where those are not part of the path. Let's just say someone renamed some piece of malware to bitsadmin.exe or some other tool to bitsadmin.exe, hoping to fall into the background there. I would want to look for instances where bitsadmin is not in those paths. There's detection opportunity number 1. This one here was in System32. So I know we're good. It was in a legitimate path. Okay. Doesn't mean it was a legitimate file or a legitimate invocation. It just means it's in an expected path. If I dig down a little bit further, we'll notice that every time an adversary abuses bitsadmin, or every opportunity there is to abuse bitsadmin, there are flags and parameters that are provided after that particular call. Well, luckily for me, I'm going to have the ability, especially within LimaCharlie, to capture all this visibility and all this telemetry. So the nice thing about this is, if someone goes through and they run one of these particular commands right here, I'm going to hopefully be able to see if I can capture it from those command lines, if I can see it from those command line perspectives. And I've got an interesting little tidbit for everyone here, which I'll share with you in just a moment. But that being said, we are going to wait and see if we capture some of these command lines, but that's going to give me another opportunity to detect. So let's expand that detection rule just a little bit here. So I could go a step further and say, you know what? I don't want to just pivot every time bits admin runs. I want to change a few things here. So I'm going to expand my search here. I'm going to expand my particular my particular rule set. I'm going to look for a couple of different things here. I'm going to keep that earlier contains that we had. Meaning I'm going to say, all right, I want you to contain instances, or I want you to match on instances where bits admin gets matched as part of the command line. We're going to start there. Okay. And I'm going to say another operator. And again, I'm just thinking out loud about writing this detection response rule here. I'm going to look for instances where the command line might also contain the word add file. Or I might look for instances where it contains the word create. Because if I notice across all three of these different features or all three of these different examples of how bits admin can be used, /create is in every single one. Well, hold on. Oh, there's a fourth one that has create in as well. Well, hold on a second. We have to go a step further. And this is where, folks, we have to play and understand a little bit about how these things might be used legitimately. If every single time an adversary utilizes this particular tool, the /create is in there, maybe this is a required functionality of the tool. So searching for bits admin and /create is only going to give me the exact same number of searches as if I just searched for bits admin. And if you notice, there's a lot of things that are very consistent about that as well. So bits admin, bits admin, bits admin, bits admin, /add file, /create. There's a lot of consistencies in the way that these particular commands get run. And what I might not know just by looking at these is that a malicious invocation of that binary, or is it something that is always going to be part of that invocation? Which means if I write a detection and response rule, am I going to catch system activity and adversary activity? Now, let me pause right there. In the scope of detection engineering, in the scope of writing a detection and response rule, that's okay. It's okay to write a detection and response rule that captures both. And then we whittle down the legitimate activity, looking obviously for only the malicious activity. It's okay to be in that position. I would rather you go that than try to cut too much out before we take the detection and response rule live, which is exactly what I'm going to try and do next. So do as I say, not as I do. But one thing that I found to be a little bit of a concerning point is this opportunity right here, this area. This area where an adversary might be using bits admin to download a particular file. And the one difference that I get, creating an alternate data stream, downloading, copying, and executing, download is or should be the only job that might reach out to an external source, hence the download capability. There is an opportunity for me to capture potentially something unique. Now, you might say, well, Matt, what if this tool's whole general purpose is to reach out to an external source and download stuff? Background intelligent transfer sounds like what it's designed to do. Absolutely, 100%. But again, I'm looking for something I can use as a differentiator, as a pivot point. And maybe, just maybe, I'll get lucky and see, maybe I can use this to detect some external download activity. Now, let me drop a quick note for everyone here and say that this particular command is reaching out to sysinternals.com and downloading auto runs. So this is actually a benign example of how to use bits admin to download. So I'm not worried about running this command inside of a test environment that I've got set up there. But I will just note and say that the idea of including a web address inside of there is one that I find to be very interesting. So let's head back over here. And I'm going to look for instances where the command line not only contains bits admin, but also contains the value HTTP. So let's walk through and talk about how I've expanded on this detection and response rule a little bit. We're starting with that new process event of bits admin, and I'm looking for a couple of different parameters here. The first one is obviously bits admin. I want bits admin to show up. Now, we could go a step further if we wanted to, and we could work on the different paths, and we'll talk about what that rule looks like in just a moment. But I'm just going to do a really simple search looking for bits admin and where the command line contains HTTP. So I'm kind of combining things together here. But I'm going to go ahead and change the name of this particular report and call this bits admin download activity. The only thing I have to go off of that tells me that it's a download is an example where I see someone reach out to an HTTP site. Now, before anyone does this, before anyone jumps in the chat and says to me, well, Matt, what if they use an IP address and they don't? I'm aware there's lots of ways to subvert my detection rule on the surface, but hang tight. We're just trying and seeing what happens here to see if the thing that I expect to see gets detected via my detection and response rule. Remember, my goal right here, and welcome to detection engineering, folks. My goal right here is to just write a detection, apply it, see what comes back, hone and craft if I need to. Now, we got 0 events in this case, but I'm going to go ahead and offer another kind of filter here. I think I should have had one fire in the background. We'll see if it shows up. But what I'm looking for is to say, all right, let me take that command that's in the LOL BAS site over here. Let me go run that in a Windows environment, in a test environment, and let me see if it comes back. And sure enough, we get a hit. Now, this happened off screen, so none of you would have seen this. It happened in a VM that I got over to this side. If you ever see my eyes look over this way, I'm looking at a test VM that we're going through here. And take a look. I actually took that bits admin command and I dumped it right into the command prompt and I just ran it right there. Now I've got a little bit more of a qualifier of bits admin activity. It's got my reporting name for bits admin download activity, but if y'all remember, we had 3 bits admin events earlier. I've only got 1 in this particular case here. So I was able to bring my population down. Now, 3 to 1 might not be anything that gets anybody excited. Just tack as many zeros as you want onto the end of that, and it all of a sudden becomes really exciting. Let's say I had 300 bits admin false positives, and I knocked those down to 100 by simply dropping in a really quick inclusion rule inside of my detection and response rule. I'd be pretty happy with that conversion rate. Absolutely. That's number 1. Number 2, I might want to pull on this a little bit further and say, well, now I've got a way to detect HTTP or bits admin download activity. But Matt went a step further and said, well, what if someone uses an IP address, then they don't use an HTTP, so therefore they're going to bypass this thing? Totally possible. There's other ways inside of LimaCharlie for us to, of course, go a little bit further. So hopefully everyone sees where I'm going with this. We can go a step further. We can go and bury some of these rules in here and say, rather than having this type of, rather than having something constrictive in here, and I'm typing this out as I'm going through it. There we go. I wanted to be right there. Rather than saying, show me bits admin plus HTTP, let me go a step further. Let's go back to LOL BAS and say bits admin. I want to look for instances of HTTP because that's going to show me external connectivity. But I might also want to see instances of either an IP address or a .exe or a .dll or something like that. Now, this is where I've got to be a little bit careful in the way that I craft this. I can't write a detection and response rule that says, show me every time you see bits admin with an exe in the file path. Because guess what? It's going to already be present inside of the event. Bits admin is already going to be present inside of the event. And in fact, if I scroll down here, you'll notice that all I was looking for in my contains here was instances of bits admin being inside of the command line. However, folks, we can tweak this a little bit and make it a little bit stronger. I don't want to look for instances of bits admin in the command line. I want to look for instances of bits admin in the file path. So let's go here and change this up. I'm going to convert this to file path, and we're going to ask it to contain the value bitsadmin.exe. And I'm looking right here at this rule right here. I want to modify this and say, show me every time the file path contains, and you could also do this if you wanted to as well, ends with bitsadmin.exe. I'm going to capture system32 and syswow64, number 1. 2, I want to go and pivot on this. And I want to say, regardless of where it is, regardless of what's happening there, I want you to capture instances where the command line contains HTTP or exe, either one. I'm interested in either one. And what I did is instead of pivoting my detection and response rule entirely on just the command line parameters, I'm now going to expand a little bit further. And I'm going to say, show me instances of where bits admin is the file that was called. Hence this example right here. Show me instances where bits admin was the file that was called, but show me instances where the command line contains either HTTP or exe. We're going to run this rule. It looks like I had a typo in that one. Let's go ahead and replay that against our environment to see what comes back. But this is how we can craft a rule that is a little bit stronger and a little bit more resilient to catching a lot of normal system activity, pivoting off of what we know about the way that this particular event is being abused. And if I scroll down, you'll take a look. We actually got 4 detections in this opportunity. So earlier on, some of you may have noticed, well, wait a second. First we had 3. Now we've got 1. Now we've got everything that has popped up in this case for one key reason. Take a look. Every single time bits admin was called prior to our HTTP event, it was called directly as, and I'm going to zoom in on this event, it was called directly as bitsadmin.exe. It was only in that final example that I removed the .exe and just call bitsadmin straight up. Again, the power of the Windows command line, I don't need to include that .exe. It already knows what I'm looking for. But I can use that to potentially write either really strong detection and response rules or ones that have a little bit of flexibility as they detect commands across the environment. So that's one way of going through and kind of testing and seeing what you're looking for. And what I did in this case here is I grabbed this command from this particular resource. I ran it inside of a test environment that has LimaCharlie installed. And I went back and I said, hey, LimaCharlie, show me instances where this thing has happened. Notice I didn't do anything against production. I'm not, inside of an environment running bits admin against a sensitive system or critical system. I'm testing my detection and response rule before I deploy it across the wider environment. I'm going to go ahead and save that particular rule because I like the way it looks and it's captured some things for me. But I went from just having bitsadmin.exe to now pivoting a little bit further into what might be some potentially suspicious activity for me. But in this case, I was also able to go through and label it as potential download activity, which gives my analyst a much easier way to jump into the environment and say, boom, here we go. Now, digging into the unique attributes of some of these files is one way to find out what it should look like and what it should be. I've got to point y'all to another really good resource here, the Sans Blue Poster, as it's affectionately known. And I know this one's a little blurry to see. I'll throw a link into the Slack channel here for everyone. But the Sans Blue Poster is another really good example of legitimate binaries inside of the Windows operating system and things that you should expect to see when those things are active, when those binaries are running. Now, Blue Poster here does a really good job of picking out really, really default executables because these are mostly things that you're going to see during a system boot up and systems. And it's going to drop in all sorts of types of qualifiers, such as what types of things you would expect to see, where the process should be located, the number of instances that might be running, all sorts of things that I would call kind of like the normal side of what that process should look like. And that's going to be a really, really useful resource to have, because if I'm going to go through and I'm going to craft detections, knowing what the process should look like versus what it does look like, I'm going to utilize a resource like that in order to help identify and say, all right, this is where this thing does not appear to align with what I would expect to see. Another really cool capability that we've got built into LimaCharlie that I'd like to make sure everyone is aware of. Hopefully you remember at the beginning, we talked about that LOL drivers. Let me hop back to that just so you can see and remember what that is. LOL drivers is that instance of living off the land drivers, a list of Windows drivers that can be used and abused by adversaries. This is actually a downloadable, or I should say a really easy API-able data source. So we've actually integrated and built it into LimaCharlie as well. It's a lookup that you can utilize. And it's a really useful lookup because it works off of the hash of that particular driver. So remember, the list of this data has hashes, SHA-256 is associated with some of these malicious binaries here. So in this particular living off the land feed, and I'll show you what that rule looks like in just a second, we're actually able to pivot on the hash event that comes up during the code identity and see, hey, has this particular driver had a match against the LOL drivers data set? And I'm really, really hoping I don't have this happen inside of my environment, because it would definitely be a bad thing to happen. However, a detection and response rule is going to look a little bit like this. And there's an example in the add-ons marketplace as well, but it's going to be really straightforward. Whenever that code identity event pops, which is not a process execution, but it's an event that hits whenever a binary is recognized on the system. it's going to grab that SHA-256 as part of that event. And that's going to be an event I can push against that lookup. And I'm going to get back some information against that driver if it is indeed located inside of the LOL drivers data set. I promise y'all, we will likely have the same types of integrations coming up for GTFO and Lubins as well. It just depends on the ease of setting it up as an API or some sort of a dynamic lookup. But nonetheless, very, very useful resources to have. I do know for a fact that Lubins does have an API capability. I would not be surprised if you see this one come to LimaCharlie sooner than later. So from a detection perspective, we can craft our own custom detection and response rules based off of what we've seen. We can also, we can also utilize external resources such as LOL BAS, LOL drivers, GTFO bins, lube bins, so on and so forth. There we go. I can also utilize some of the other native rule sets that are built into LimaCharlie, such as things like the Sigma rule set. Sigma rule set is going to have a wide range of detection and response rules that can detect this type of activity. They're going to be able to easily jump in and say, hey, here's a whole swath of rules that will go through and detect this malicious activity. And I know that because these rules are actually listed right here directly inside of our LOL BAS resource. I can click over and drill directly into this right here and see, hey, what is this thing looking for? What are the resources and what types of things are being found here? And take a look. Sure enough, one of the parameters that they're looking for on that side is also the inclusion of an HTTP, an HTTPS, FTP, or FTPS. And it's just a nice confirmation for us to see some of the other capabilities that's in there. If I drill into these a little bit further, one other thing to remember, folks, as you're writing these detection and response rules is that these files are going to be captured or they're going to be represented on the system in different ways. So, for example, a binary bits admin or VI or 7-zip or whatever it might be is likely going to be captured as a new process event because it will be the source root process itself. For example, remember when I invocated bits admin, I was calling bits admin itself. It was the binary being run. System files drivers might not necessarily be the executed thing. They might not be the file path that's being run. They might be more present in the code identity event, which I've already talked about, or they might be present in the command line parameter itself. This is where you're going to have to flex a little bit on those detection and response rules and say, when I'm building this thing, is the detection that I'm looking for going to be located inside of the command line parameter? Is it going to be located inside of the binary path? Is it a hash? What type of event is it that I'm actually looking for here? And that's going to be an important distinction as we bring some of these rules together. I'll drill a little bit deeper for just a moment or two into some of the other activities that are happening here. I like picking on Ditto because Ditto is a really good example inside of the Mac environment. Ditto is one where, again, I can gather and compress files from a specified folder and write them out to a zip. So in this chance right here, or I should say in this detection opportunity right here, I'm not so much concerned with what or how the file is being run, but maybe more what the file is creating. So in this case, I'm not interested necessarily in the command line parameters. I'm interested more in what is this thing doing? What does my output file look like? So my pivot point might be the final stage of that command rather than the initial upfront parts. And of course, the last and final little pro tip I've got for everyone here, when you're going through and you're doing living off the land detection engineering, another thing for you to consider is this even normal in my environment? And this might be another opportunity for you to really quickly either identify malicious or suspicious activity just by simply baselining what happened there. If I went and ran that bits admin rule that I did against the environment, you might have noticed that within the past 3 weeks, we had 4 events pop. Based on the running of the windows and systems I've got in this demo environment, based on their normal execution, I would argue and say that over 3 weeks of process runs, 4 events, bits admin is not normal inside of my environment. It is not a common or frequent application. I pick on Ditto again. Ditto might be another example of where I know this thing is built into Mac, but none of my Mac users know or even understand how to use this thing. So therefore, I might not need to write a detection and response rule with so much granularity. Sometimes I can just say, well, the sheer presence of this thing running is already itself an anomaly to what's happening out there. This might be a good opportunity for me to write this particular rule. Now, I want to come back to bits admin, and I want to mention one other little piece because this is another important part of detection engineering. It's off screen for you all right now, but when I went and I ran bits admin inside of my test environment over here, I got back an error message from Windows that said bits admin, and I'm in a Windows Server 2016 instance over here. It came back and it said bits admin is deprecated and not available or not guaranteed to be available in future versions of Windows. Administrative tools for the bit service are now provided in bits PowerShell commandlets. Let me summarize that into a detection engineering speak. This particular tool is not going to be available in the same fashion in future instances of Windows. Now, I'll be the first to say one of Windows' greatest claim to fame is backwards compatibility, which means if I upgrade my fleet to Windows 11, but I'm still utilizing scripts that were written during Windows 7, I want those things to be able to run without too much conversion over. So a lot of times, what you can also use LOL detections for is to find instances where someone is utilizing a legacy tool or a legacy approach in your environment, which again, in itself stands out. Because I might have a team of administrators who know how to use PowerShell and use bits admin PowerShell commandlets. In that instance, I'm able to then say, well, we use bits admin, or it's an ongoing feature within our environment. However, my team calls it one way, an adversary would call it another. Long story short, every single one of those attributes, every single one of those bullet points is another opportunity for detection and another way to say, you know what, adversaries, live off the land all you want. I can write and craft detection rules that will pick apart every little single thing you do and turn it into a really good detection opportunity. All right, folks. Well, with that said, that's our final loud and clear episode of 2023. This was a review of living off the land, binaries, drivers, executables, scripts, whatever it might have been. I hope y'all enjoyed this session. A huge thanks for being here with me today. I will be posting some links and some snippets of code into the Loud and Clear Slack channel. Please definitely join me in there. Otherwise, thanks for being here with us. On behalf of the folks at LimaCharlie, we've got a lot of awesome content coming up. I don't know if this will be the last webinar for 2023, but if it is, I can't wait to see you all in the new year. If it's not, then I'll see you on the next one. But in either way, it's great to have you all with me here today. With that said, take care, have a happy holidays, and see you all on our next event.